Well, this is the first of two videos that we're going to do on graphing. So the Cartesian plane is what people call, what is sometimes also referred to as the coordinate axes. So, and this is a two-dimensional figure. We have horizontal and a vertical axis. The horizontal axis is like a regular number line. Okay, the positive numbers go off to the right, the negative numbers go off to the left, and we call this the x-axis. Okay, the vertical axis is called the y-axis. And here the positive numbers go up and the negative numbers go down. So this is sometimes called a coordinate axis. It's also referred to as the Cartesian plane. That name comes from René Descartes. René Descartes was a French mathematician. And he worked in the early 1600s. It was around 1620 or so, and in the subsequent years following that he did a lot of his work. There's a story about René Descartes lying in bed watching a fly crawl across the ceiling, which was a checkerboard ceiling, and he tracked its movement by seeing how many boards he went to the right or up or down, and it was a way to keep track of where the fly was moving in reference to an original point. Okay, so I'm not sure how true that story is, but this is a way that human beings have used to track movement or position. Okay, for centuries. It's used now in a slightly different form for our latitude and longitude. You know, spherical coordinates are a little bit different. The plane refers to the fact that this is a flat two-dimensional surface, whereas spherical coordinates are used for latitude and longitude. Okay, but they're used on a spherical system, which is a little bit different. So we're going to focus on the two-dimensional system. And if you go on in mathematics into an area that uses latitude and longitude, you may become familiar with spherical coordinates. Airline pilots and anyone who's flying frequently use those ideas. Okay, so, well, let me finish writing coordinate axes. Okay. Again, the horizontal piece is called the x-axis, and the vertical one is called the y-axis. And a point on this system is called a coordinate. Okay, so let's look at the assignment here. The assignment is just about graphing these points on the coordinate axes. The points are always given in the form x, comma, y. So you've got the horizontal position given first, and then the vertical position given second. So, in problem 2, we've got the point 7, negative 4. So, the x-coordinate comes first, so we go over to 7, and then we go down to negative 4, and there's problem 2. Problem 4 is the point negative 1, negative 3. So again, the horizontal position is given first, negative 1, and then the vertical position is given second, negative 3, and that's problem number 3. Now this point in the middle is often called the origin, and its coordinates are 0, 0. All right, let's see here. Problem 6. We've got the point 2, negative 3. So the horizontal or x-coordinate is positive 2, and then the vertical or y-coordinate is negative 3. And and that is problem 6. This is problem 4. There we go. Okay, let's see here. Well, let's look at one more, and then I'll clean up our coordinate axes here to do a couple more. Problem 8 is 2, 0. So in this one, the horizontal position is 2, the vertical position is 0, so we don't go anywhere, and there's problem 8, and that's the point 2, 0. Let's see, let's do a couple more here. Problem 10 is the point 0, 1. So if we start in the middle, this is telling us the horizontal or x-coordinate is 0, so we don't go to the right or left, we stay right in the middle there. And then the vertical or y-coordinate is 1, and so there's the point 0, 1. Okay, so this is getting a little bit messy, so let's clean it up and give us some more space to work on here. There's the negative y values. Okay, so let's look at a few more problems here. Problem 12 is the point 4, negative 1. So we go over to positive 4 on the x-axis. We go down to negative 1 on the y-axis. And there's problem 12. Problem 14, 0, negative 2. So again, we start in the middle and don't go to the right or left because the x-coordinate is 0. And then for the y-coordinate, we go down 2 places to negative 2. And there's number 14. Number 16 is 0, negative 5. So that's going to be, again, 0 on the x's, negative 5 on the y's, and that's number 16. Number 18 is the point 4, 2. So we go over to 4 and then go up 2. That's number 18. And then the last even problem here, problem 20. This is the point 8, 1. So we go out to 8 on the x's, up to 1 on the y's, and that's problem 20. Okay, so this first assignment is relatively straightforward. It's important that you understand that the first number is always the x, or horizontal component, and the second number is always the y, or the vertical component. And it's also important that you understand that the x's go positive to the right, negative to the left, and the y's go positive up and negative down. Okay, so that's it for this assignment. In the next assignment, we'll look at substituting some values in to an equation, okay? Because that's one of the major advances that this graphing on the Cartesian plane was responsible for, and I'll talk about that a little bit more in the next video. As always, if you have any questions about this, please let me know.